Okay, I'm again distracted, but moving on to the challenges to operationalizing resilience, let's look at some technical and environmental challenges which will be simpler compared to the human bias and social challenges. In addition to cognitive and social constraints, there are various related technical and environmental limitations to developing resilience. Many of them are, in one way or another, associated with the complexity of human environment systems. It's, in other words, rarely possible to address any one challenge in such a system without affecting something else in it. We looked at the piping diagram for the Earth system. So you tinker with one thing like greenhouse gas, it cascades into many things. Or deforestation as another human activity. Small changes in one place and at one point in time may have substantial impacts somewhere else on another scale or much later. So time, space, delay. Hence, the complex systems are liable to behavior that is locally adaptive but globally maladaptive in both spatial and temporal terms. This is very important because adaptation is very much local, because you have local risks of climate change. Nobody lives in a global mean temperature, global mean sea level, and so on. So when you say global warming and sea level rise, you have to come back to local scales, and then adaptation has to happen. But then how do you make sure that your adaptation is not going to become maladaptation for somebody else? Variables in human environment systems may change without human beings doing anything, and entire systems can evolve over time, rendering what worked yesterday useless today. So natural variability is not going to go away anyways. This is particularly troublesome for resilience, since such systems have been shown to be prone to get stuck in adaptation strategies that were successful in the past. Agents in the system thus fail to grasp the current challenge and focus on proven solutions. Human environment systems are also likely to exhaust its capacity to adapt when disturbances escalate and cascade faster than the system can adapt. This is referred to as decompensation and is a vital argument for why it's dangerous to allow a human environment system to drift toward anticipated tipping points. So if you know that the system is heading to an unsustainable situation, what can you do about it? It's not always easy, though. The environmental technical challenges we'll see will make it clear, but we have plenty of examples of that. In the sense, let's say sea level is rising, cyclones are getting more intense and increasing number, and your coastal population centers are getting hit harder and harder, and coastal erosion is becoming worse and worse, and salty water is getting into groundwater, fish are disappearing, and so on. And you want people to move away from the coast, but they will refuse. So this is a combination of technical challenge of protecting the coast, environmental challenge of managing groundwater and fisheries, and social constraints on people not able to get up and go even when the situation becomes untenable. In history, even in the Holocene, we have had many examples of civilizations disappearing. There are debates among social scientists about whether civilizations actually go extinct or they just merge with other civilizations, migrate, and so on. Nonetheless, as evidences continue to accumulate, we may get a better idea. But there are huge signals of environmental change associated with such extinctions, let's say, for simplicity. Mayas, Incas, Mohenjo-daro, Harappa, Mesopotamians, Babylonians, African civilizations going away and coming back to the Nile, and so on. So other thing to notice is that elsewhere I have discussions on the Holocene climate change. The changes in temperature over the Holocene were order half a degree. Okay, so even the small perturbations such as these, which were mostly related to orbital forcing, precession, obliquity, and ellipticity, etc., human activity had started, but there is no clear evidence that they contributed significantly to the change we have seen over the Holocene. So in that situation, what does it mean when we are warming so much more now? After beyond the Industrial Revolution, we are now more than 1.2 degree centigrade above that level, and this year 2024 is coming out of the big La Nina of 2023. 2023 crashed, broke all records on warming and disasters and so on. 24 we watch carefully to see if it will begin to cool down compared to 23 because of the La Nina that's coming following the El Nino, are expected to come, predicted to come anyway. So what can we learn? Are we still going to face heavy impacts like we did through the Holocene, or we have become technically so powerful now that such perturbations don't matter? If you read the numbers, US had 2.5 million people displaced by disasters in 2023. So rich countries like this, which consider themselves quite invincible, are also being seriously affected. Of course, who pays the price always depends, that as we discussed in the case of Katrina and New Orleans, the socioeconomically vulnerable end up paying a much bigger price than the rich people. Nonetheless, and that's within the same country or within the same state or even within the same city. Nonetheless, as humanity, we are doing fossil fuel consumption, increasing greenhouse gases and so on. So what are the technical abilities we have to deal with these challenges to resilience? Again, remembering the resilience being the way to stay on a path to sustainable development. Right, so we have to bring all these ideas together. We'll come back and look at administrative, political, legal, and economic challenges. I wanted to leave the technical and environmental challenge podcast here, even though it's only about 7 minutes. But you need to think about this, because the details, there are some more discussions in the book that I didn't include. You can imagine many technical difficulties that superpose on intrinsic human tendencies. Moving away from the coast is one thing. We've already discussed evacuating during cyclones on a shorter time scale. Moving away from the coast permanently is a big deal. In adaptation, we talk about how adaptation is an intervention and it needs to incentivize people and firms to deal with such risks, but you also need to plan for providing them livelihoods when they are displaced voluntarily or forcefully, and firms need to have contingency business plans to deal with changes that are imposed on them or required of them, or they do it to deal with climate risks that are evolving over time and so on. So this is quite a tough game which has many dimensions. We are perturbing the system. The system is having cascading effects. As we said, sea level rise, cyclones increasing, rainfall associated with them increasing, rapid intensification. Cyclones can move slower and dump more rain, or get stalled at the coast and dump more rain. And more people are coming towards the coast. Urbanization is happening, which increases the runoff for the same amount of rain. And nutrient pollution increases, which affects the fisheries at the coasts. And so, you can imagine infinite cascades, and decisions have to be made. Resilience has to be built beyond coping with disasters. So we'll come back and discuss the other challenges like economic governance and so on. Okay.